So I found a trick when we're dividing by numbers. So pretty much, it was a while ago. I'm currently age 17, but I was probably 15 at the time. I'd been watching a lot of number file videos, so my head was full of maths, and one night I was in bed, and I was thinking about numbers as everyone does in bed. I didn't know how to do short division, nor long division with just normal integers. So I was always looking a way to convert a fraction into a decimal, and out of nowhere, it was probably 1 in the morning, this idea just came to my head. So I jumped out of bed, probably stayed up till 2 in the morning just messing with this idea, and I was just so excited that I couldn't even sleep. So here's what I found, and then I followed up on this with this really interesting property when we're dividing by 7. Let's just give a random fraction, maybe 4 over 7. What we do, we want to get this denominator to 100. So if we do 100 divided by 7, multiply by the whole fraction, it's going to get us to 100, and that'll give a decimal place on top here. So we have this thing, which is a magic number, which is going to be 100 over 7, and we want to put it into a proper fraction. That gets us 14 into over 7. And you want to look at this, and you want to be multiplying the numerator by this magic number. The first one we get is 56, and 8 over 7. And then you want to keep putting this back into its proper form. So now if you write 0 and grab this number here, so 57. Now we've got our new numerator number here. Multiply this by the magic number, and this just gets us to, now this is our new set there. Grab this numerator, multiply it by this, we get 28 and 4 over 7. So the 28 goes here. And what we notice now is that the 4 over 7 is the number we started with, which means when we multiply this by 4, this is going to bring us back to here. And that's where we get our loop. And that goes on forever. So I was tinkering with this a bit more, and I tried some other numbers. What I did next was I divided probably 1 over 7. And of course we know that the magic number is going to stay the same. 14, 2 on 7, as we have before. The same numbers are showing up. 57, 1 over 7, and then look at that. The 1 over 7 right here is the number we started with, which means this is going to go on forever. And I looked at these, and I realized that it's the same sequence, just starting on a different number. For 1 over 7, it starts on the 1. For 4 over 7, it starts on the 5. And I tested these out with other numbers, and what I found out was that there is definitely a pattern to it. There's 1 over 7 was 0.17, 2 over 7, 1, 4, 3 over 7, 7, 1, 4 over 7, we got 5 over 7, 5, and 6 over 7, 4, 2. And these are all the same order of numbers, just starting on a different number. After doing a bit of testing, I found out a really interesting pattern. What I did, I wrote the numerators under here. So if it's 1 over 7, the 1 was here. If it was 2 over 7, the 2 was here. 3 over 7, we started at this number. And I realized that it starts at that number's smallest number. If it's 1, it starts at the lowest number. If it's 2 over 7, it starts at the second lowest number. 3 over 7 starts at the third lowest number, and etc. And now, pretty much, we can divide any number by 7. 532 divided by 7. Well, I know it goes into 409, so we could write 70, and the remainder is 42 on 7. Well, that's not a very good example, it just gets us 76. Maybe another one, 681 divided by 7. I know it goes into 63, so I could go 90, and what's left over is 51. Now if I figure out 51 over 7, we know that that's going to be 7.285714, therefore it equals 97.4, etc. Let me just quickly check that. 97.28, there we go. So I started to do some more research on this. I didn't find anything on the web about this idea. I was wondering if it would work with other numbers, maybe like dividing by 13, where it still has a recurring sequence, or dividing by 19, and the same pattern didn't work for that. I'm still looking for any other numbers that has the same property. So my conjecture is that 1 over 7 is the only number that has this property. Well, in its prime form. Obviously we could do 1 over 14. Since they're all grouped in 2s, we grab the first one. 14 divided by 2 is 7, so we write 0, 7. 28 divided by 2 is 40. 57 divided by 2. Got to be careful here. So we do, since it's an odd number, 57, we get 28.5. So we write the 285 here. And if we grab the 1, 4 again, we get 0, 7. But because there was 3 here, we add the 0 to this, which means we just put a 7 here. We see that this 1, 4, 2, 8, 5, 7 pattern. And if we wanted to do 1 over 28, 0.07 divided by 2 is 0.035. 07, which means we get that 5728 right after that. 1 over 56, we get the 03 at 0.15, but I don't want to add that yet. We get this. It's going, that 2 is going to add to the 5 we currently have here, so to get us 7. And look at that, we got the 5, 7, so now we know it's going to be 1, and so on. So what I'm really interested to see now is if anyone can find this same property on any other number that we're dividing by. Because I haven't found any yet.